welcome back. Hope you had a very nice break. As you can see, at the moment I have lost my co-host. He might be back after this talk. And yeah, but so far I hope you had a great day. I hope you did some networking and checked out our sponsors and also have checked out our hashtag on Twitter, which is hashtag WTFSSRE, to tweet about all the amazing talks that we've had. And so far, we've had a lot of cool talks here on track 3. And the next one is just coming up. And I would like to welcome Martin Mao to the stage now.
Hey, everyone. How's it going?
Hi, Martin. Thank you so much for joining us. Are you excited to be here?
I am super excited to be here.
Awesome. Very cool. So to remind everybody, if you have any questions for Martin that you want me to ask him after his talk, then please leave them in the chat box next to the screen or next to this little window here. And I'll ask him your questions. So yeah, Martin, you can go ahead and kick off your talk, which is called Is MTTR Still Relevant in a Modern Cloud Native World? So we're all very excited.
Fantastic. Again, great to meet everybody here. Hope you're having a great day. As Eva said, my talk is about whether MTTR is still relevant in a modern cloud native world. Quick introduction about myself. Let's see if these slides are working. Currently the CEO, co-founder at a company called Chronosphere. We provide a hosted observability solution aimed at cloud native environments. Previous to this, I used to lead the core observability team at Uber for a few years, and we built open source observability solutions such as M3 scalable time series database, as well as Jaeger for distributed tracing. And previous to that, worked at companies like Microsoft and AWS. But enough about me. Let's jump into this. So the origins of MTTR, if we look back in history, actually comes from the Department of Defense in the 1960s, and it stood for mean time to repair. And it was trying to measure how, or what the average time was to repair a failure in military equipment, and the reliability of military equipment is originally where that term came from. So a little bit of history there for you. And of course, we've been using that outside of hardware and military equipment since the 60s in a lot of our systems these days. And we do use MTTR a lot these days. And perhaps the first small issue with MTTR is when we look online these days, there's actually many definitions of MTTR. The R stands for a lot of different things. Originally stood for repair, but we often see that it can also stand for recover, respond, resolve. And the bad thing about it is that these words are not necessarily interchangeable. If you have a look at this somewhat complicated diagram here, when we look at the mean time to repair, the mean time to recovery, the mean time to respond, they're actually measuring slightly different things. So that is the very first thing that is somewhat confusing about MTTR. But for the purposes of this talk, we're going to assume it means repair, which was the original meaning, which is the time to repair a issue here. And when we look at that a little bit, there's perhaps two parts of it that make it potentially less relevant for our modern cloud native architectures. The first part is the first word, which is mean. So, you know, we're measuring the average of something. And if you think about how we measure a lot of things and how we give our customers and internal users SLAs these days, generally we're not giving the mean time or the average time. We're really trying to look for the outlier time, the P99, right? If you give somebody a latency SLA, generally you're promising a P99 latency, an outlier latency, as opposed to just the average latency there. So, you know, perhaps mean these days is perhaps less relevant than our outliers in a lot of our modern architectures. And then the other part that we do want to revisit, visit a little bit and see if it makes as much sense, is the last word here, which is repair, which is, you know, how long it took in our software systems, I imagine, how long it took to repair an underlying issue and fix the root cause. And, you know, for that, of course, it is definitely an interesting thing to look at to see how long it takes us to fix issues. But if you think about a lot of the reasons why we even build our systems these days, why we even use container-based infrastructure, it's really to be resilient and be available as much as possible. So often our systems are designed to, you know, potentially be in a active running mode and be easy to restore to that mode and retain our SLAs while we take the time to fix the underlying issues there. And we can definitely talk about that a little bit more as well. But these are the two concepts we want to deep dive into and see if they still make as much sense these days. So first one here, looking at the mean time, and we have two examples here, two services here. And if we're looking at the mean time to repair, both averages out to about 180 minutes, which is three hours. But if you look at service A, all of the times are around the same time, around that sort of 3 hour mark is how long it takes to repair that service. Whereas if you look at service B, you see generally it takes less than 15 minutes to get the service repaired. However, there's a huge outlier at over 600 and over 600 minutes there, and you can imagine that the means of these things are the same. However, you can imagine for service A and service B, they're very differently shaped data, and in fact, that outlier, perhaps causes issues here, because you can imagine if you're trying to keep an SLA to somebody to resolve a service, that outlier is going to clearly break that SLA here. So this is where using the mean perhaps hides a lot of our outliers in our data set there. And you can imagine if we were to describe these services, you would describe them fairly differently, and how long it takes to repair issues fairly differently. However, they have the exact same mean time here. So that's looking at the mean there a little bit. Looking at the time to repair, here we have a timeline of perhaps what typically happens when there is an outage. So, you have your normal operations, your system or your service is operating, and your infrastructure is operating as per usual. Perhaps we're doing a deployment here, and we're deploying some break and change to our system. You can imagine generally, unless it's at the infrastructure level, generally when you don't touch a system, things don't break. So often it's when you introduce a change that things start to break. So we introduce a breaking change, and then ideally we would be notified of that, and an alert gets triggered that tells us that this change has broken in some way. Either we're returning errors or we have really high latencies now. You can imagine the very next thing we may do is roll back that change, because we caught this while we're actively deploying something out. We may not know at this point what the underlying root cause was. We don't know what was wrong with the code, what introduced this perhaps much higher latency, or what introduced this source of errors. And we don't necessarily want to know right then when the system is broken. You can imagine as you're trying to roll something out, and you notice something is wrong, that the natural human reaction thing to do is to roll it back as quickly as possible, get the state back into a functioning state there. And perhaps it's not just with code changes. You can also imagine at the infrastructure level, if your database node is running out of disk, the very first thing you may do is perhaps not go and figure out why it's running out of disk so quickly. Perhaps go expand the disk thus that it won't fail. And then, you can imagine take the time to really understand and root cause the issue, right? And of course, once you roll back the change here in the first example, and we are in a normal functioning state again, where we're meeting our SLAs again, then you have the time when the system isn't down, when your customers aren't impacted. You have the time to really then dig in, figure out what was wrong with that change that you tried to introduce, and you can imagine redeploy a new version. And you do need to do that because you can imagine you still want to continue to move forward and deploy, but you can take the time to go do that, and it's not under the pressure of the system being broken and your customers being impacted. And of course, once you roll out that change successfully and figure out the issue, you can sort of resume normal operations again. And on this type of timeline, you can imagine there's a few different things here. There's obviously the time to detect, which is the moment between when the breaking change was introduced and when you started to be impacted, and then how long it took to detect that. And that's obviously historically been MTTR, and that's very important. And then there's a thing here where the measurement between that breaking change and when the issue was remediated, which we call time to remediate. So when you rolled back the change, even though you had no idea potentially what caused it or what the underlying issue was, you got the system back to a functioning state by rolling the change back, or by expanding your disk. And that is your time to remediate there. And then your time to repair is really how long it took you to understand what the underlying issue was and make the code changes to fix the underlying issue there. And for us, it perhaps is a lot more interesting to look at the time to remediate, because that, you can imagine, directly correlates with your SLAs that your services give, and how up and available your service or your piece of infrastructure is. So perhaps as opposed to looking at mean time to repair, we are proposing for our modern systems maybe a additional, and it's not necessarily a replacement, because we do think that knowing what the time was to fix issues is still important, but perhaps an additional measurement that would be even more useful is a concept of worst time to remediate, or maybe to shorten that, WTTR. Right. And by worst, we mean we want to look at the outlier. We want to look at the P99. And by remediate, it was how long it took for the system to get back within the normal functioning measures and guarantees that your system or your service has. And how long did it really take to sort of alleviate the more immediate customer pain there. And then you can imagine here, a very, we've changed the units here because hopefully your time to remediation is much less than 3 hours. And you can, roll things back fairly quickly, but you can see on the same type of data shape, if we apply a WTTR type of measurement to things, you can imagine that these are going to be very different now, because we're not just averaging things and we're looking at the time to remediate. And because we're looking at the time to remediate, you can imagine that's a lot more correlated to your SLA measurements and your SLA guarantees, as opposed to your mean time to repair them. And then just the last thing, to cover here is, as I mentioned earlier, in your typical observability debugging flow, you're trying to detect when something goes wrong. So you're trying to know what the issue is. You're trying to triage it. So, you can imagine the very next step is to figure out how bad is the issue, what is it affecting, and then perhaps the final step there is to understand the root cause and provide a root cause fix. And that's definitely the natural flow that you want to go through. However, as we pointed out earlier, at each of these steps, ideally you remediate the issue for your customer first, and then take the other steps subsequently, right? So, again, in the example that we had, if you know that something is wrong and you're actively introducing a change to the system, you don't even need to triage it or understand it. You would naturally just undo the change that you were doing to attempt to get the system back into a proper state, and then take the time to really understand or like triage what the impacts were and understand what the root cause was. Sometimes that's not possible. So there are times where perhaps you're not introducing a change and you do really have to understand what the root cause is while the system is being impacted. But you can imagine those times are not ideal because, as an engineer, as a developer, you're really working under the time pressure of your customers that are actively being impacted right now, and you have to debug these complex systems while the system is on fire. But that's the thing we want to leave you with, and then the concept of WTTR as well. So thanks for listening along to that. Of course, I'm happy to answer questions now. And then if you want to keep the conversation going, feel free to tweet at me. That's my Twitter handle there, or feel free to shoot me an email anytime.
Thank you so much, Martin.
Of course.
There is a question that no, there is not. Sorry.
Okay. Well, hopefully I explained things well. And everybody understands everything.
Well, you understand it in a way that I understood, so that is always a good sign.
Excellent.
Okay. So, Martin, thank you so much for your talk. People, if anybody has any questions for Martin, then tweet them at him or leave them here in the chat. I'm sure that Martin will be around for a little bit to answer your questions. Thank you so much for hanging out with us and for giving us all your insights and sharing your talk with us.
Of course, it was great. And hopefully see everybody soon.
Okay. Thank you. Bye.
Bye.
So, everybody, as you can see, I am now alone because Erie is gone off somewhere else. I would like to thank him for being my wonderful co-host today. And for hanging out with all of us. So, for the rest of the conference, you have me. Hope that's okay as well. We have one more talk coming up here on this track. But before that, we have the panel discussion that I would like to send you off to stage 1. So that is going to happen in 5 minutes. 5 minutes. Okay, so you have 5 minutes to get yourself something to drink and a bio break, and then go to the panel discussion. That is on track 1. And yes, and then don't forget to come back here because we have another talk for you. Okay, see you in a bit. Bye, everyone.